Welcome back to Trace 30 Plus Load Design 101 Part 2. Part 1 of this tutorial walked through the creation of buildings in Trace 30 Plus. Now we will continue the training by defining systems, briefly discussing plants, and reviewing the calculation result outputs. We will continue to use the same example from Part 1 throughout this video. If you skipped the first video or no longer have your example file, you will find a completed example file from Part 1 on our website. Feel free to download that file to continue working through our example during this video. Let's pick up where we left off in Part 1 and go to the Systems section of the program. The Systems section of the program represents the air-side systems that are used in conjunction with plants to condition spaces. The system is defined by its air path and the components in the air path as well as by zone-level equipment. The system is also defined by its temperature and humidity controls. Some systems have one large air handling unit with one set of coils that serve all of the zones on that system. Other systems only have a small piece of zone-level equipment to condition each zone individually. We will take a look at how to set up several different systems in this section. Available systems include variable air volume, constant volume, underfloor air distribution, double duct, and variable refrigerant flow, just to name a few. Let's look at how to select systems in the program. The first section within Systems is Select Systems. Here we will select the specific systems that will condition the building. You can choose from standard systems that come with the program or custom systems that can be created in the Systems library. For example, if you have a typical VAV system in a blow-through configuration instead of a draw-through, you can create that in the Systems library. Simply copy the standard VAV system from the library and change the fan location. As you can see in the selection bar, the systems are organized into categories. To select a system category, click the plus button next to the category name, which will then show all of the system types in that category. This includes the standard systems that come with the program, as well as user-created custom systems from the Systems library. Select the system type and click the drop-down list to see all of the library members available for that system type. You can preview the system configuration and components by selecting it from the drop-down. In our example, we are modeling an office with several different space types, including a data center. We are going to select 3 different systems to condition this building. The offices are conditioned by a variable volume reheat system, so we will select the VAV system category and expand the VAV reheat system type to see the available choices. Let's select the variable volume reheat 30% min-flow default chilled water system. You will now see the system displayed in the main working pane. If you want to select this system, click the Add System button at the bottom of the screen. If you choose not to use this system, simply select a different system to preview. You can add multiple systems to your building in this manner. After you have selected one system, you will see it added to the tree on the left side of the screen. Next, we will add the constant volume single zone system to condition the lobby. Click Add System, and you will see the system get added to the tree. Finally, add a constant volume underfloor air distribution system that will condition the data center. After you click Add System a third time, you should see all 3 systems in the tree. Keep in mind that the properties on the screen are read-only. You cannot configure any components here. You can only select a system. After all 3 systems have been added, proceed to the Configure Systems tab. In this tab, you can configure the components in the systems and define their properties. Regardless of whether the system you choose is standard or custom, you can edit the system here. The changes made to the system in the Configure Systems tab will only modify the current project and will not affect the system library. You will see that various components and controls can be added and removed from this tab. Expand the group categories for components or controls to view what can be added to the selected system type. When you select a component or a controller to add, green icons will appear on the air path diagram in applicable spots where the component could be added. When you have finished adding or removing components and controls, be sure to validate the system by clicking on the magnifying glass button, which will check the system for invalid inputs or configurations of components. This check will show you a potential list of issues that need to be fixed. If the issue is caused by a component, you can click on the magnifying glass in the validation list, and the program will highlight that component in the diagram. Additionally, on the screen, you can now define the properties of the different components by clicking the Properties button. Let's take a look at the properties for the UFAD system. Notice the 5 tabs at the top of the Properties screen, which contain a number of specific parameters. For example, system sizing information, like the sizing method and the cooling and heating supply air dry bulb, are entered on the Sizing tab. On the Components tab, you can choose which equipment libraries to use for each component in your system. The default information for this system shows a constant volume, housed airfoil fan, and air-cooled VAV packaged variable speed rooftop unit, and an electric heating coil. The Components tab is where we will enter the static pressure for each fan in our system. Expand the fan section by clicking the down arrow and input 2 inches of static pressure per the exercise information. Notice that the cooling coil here is in the unitary cooling and heat pumps category, but we can change it to be a water coil if we want. For this example, however, we will leave the default category. Finally, you can select temperature and humidity control methods on the Controls tab here. For our example, we will not modify the defaults. Now that we know how to modify the system properties, we will input the other system's static fan pressures. Select the Variable Volume Systems properties to input 3 inches of static pressure. The Constant Volume System for the lobby fan will have 2 inches of static pressure. The next step in the process is to assign building zones to the systems. If you remember back to part 1 of this tutorial, we auto-zoned our rooms in the Site and Building section to create a thermal zone for each room. Now, we need to assign those zones to our systems. In the Assign Zones tab, zones can be assigned from the building drawing. When a system is selected, plus buttons will appear in each zone that can be assigned. Simply click the plus button to add the zone to the selected system. By default, all zones are unassigned. Let's start with the VAV office system. Select this system and then click the plus sign in each of the office spaces, the conference room, the restrooms, and the corridor to assign them to the office system. Next, select the lobby system. You can choose to reassign a zone to the currently highlighted system or continue to assign any room that is still unassigned. Assign the lobby to the constant volume system. Finally, assign the data center to the UFAD system. Another way to assign zones to systems is to use the Zone Manager button at the bottom of the system tree. This will open a screen to the right of the main tree that lists all of the zones in the building. Zones will be categorized into unassigned zones and zones assigned to other systems. In order to assign a zone from the Zone Manager screen, select the system in the tree that you wish to assign a particular zone to, and then click the plus button of any zone you want to assign to the selected system. All of the zones in the project must be assigned to a system in order to calculate the file. Note that all unconditioned spaces will not appear under the Unassigned Zones category because they do not need to be assigned to a system. After all zones are assigned to your system, move on to the Configure Zone Equipment screen to make changes to the zone level equipment and terminal devices. Similar to the components on the Configure Systems tab, you can add and remove zone equipment on the Configure Zone Equipment tab. To add zone equipment, select the zone from the tree, select the zone equipment you wish to add, and click the plus button in the zone to add the zone equipment to that particular zone. To delete the zone equipment, select the zone, then select the piece of equipment you want to delete, and click the trash can icon in the tree. Each zone will have one and only one terminal device. Different zones on the same system can have different terminal devices, however. For example, let's say the conference room doesn't use a VAV reheat terminal device, but instead uses a shutoff VAV damper and baseboard heaters for reheat. We can select the conference zone, select the VAV terminal box and click the Replace button. Now, the conference zone no longer has a reheat coil in its terminal box, but the rest of the zones on the system still do. The next step is to select the wall convector and click the Add button to add it to the zone. Notice that the tree updates with the changes that are made. Notice that all of these changes occur at the zone level and will not affect the entire system. Some zones may have a particular piece of zone equipment that other zones do not. This functionality provides a lot more flexibility when modeling various system type configurations that may be atypical compared to the standard TRACE 30+ systems. After we have finished setting up our systems, we may or may not need to define some plant information in order to calculate the loads. Once you enter the plant section, the program will automatically scan your systems and alert you if you need to create plants. You do not need to create a plant in order to perform load calculations if you are using DX cooling coils and electric heating coils. The exceptions to this are VRF and water source heat pump systems, as they do require a plant in order to run. If you don't need any plants, you will see this message. If you choose to create a plant when the systems do not require a plant, you will need to assign the heating and cooling coils to that plant in order for the file to be calculated. But what happens if we have chilled water systems that do require plants to be configured? If you are using chilled water, water source heat pump, VRF, or hot water coils, these coils will need a plant assignment in the Plants tab. Again, the program will scan your systems, and if it determines that cooling or heating plants are needed, you will see this message. The program can automatically create plants for you, or you can manually go into the Create Plant section and define plants that will serve your coils. If you select the Automated Plant option, the program will automatically create a purchased chilled water and purchased hot water plant in the form of district cooling and heating loops. The heating and cooling coils will then be automatically assigned to the correct loop, so nothing else in plants needs to be done in order to calculate the file for load design. Plants and loops will be discussed in further detail in Energy and Economics 101 Part 1, which is the third video in this 4-video series. Let's continue with our example. We have a chilled water coil for the VAV system, so let's choose to automatically create a plant. The other two systems do not require a plant, so no plants will be created for them. That's it for creating this alternative. Let's move on to the project summary section to create a second alternative to do a comparison. The first tab in the project summary section is the Summary tab. This screen will show the areas of the program that are either complete and ready or are incomplete and have warnings or error messages. Notice that the System section of our file has a yellow status symbol indicating a non-critical warning. Click on the icon to show the warning messages. In this case, the program is warning us that our two restrooms and our data center have the general ventilation type selected instead of ASHRAE 62.1, which is selected at the system level. Since the ventilation to those three zones are set to 0, this warning message can be ignored. The Project Summary tab is also where you can create and define your alternatives. You can create as many alternatives in the project as you need. However, there may be a limitation based on the performance capabilities of your computer. To start, if you click the link icon in the upper right-hand corner of the alternative, you will create an exact linked copy of Alternative 1. Note that after Alternative 2 has been created, each section has an orange link to signify it is linked to another alternative. A linked alternative shares the same input data as the alternative that it was created from, and this data cannot be edited until the new alternative is unlinked. The alternative that each section is linked to will be shown in parentheses after each section name. To unlink a section in order to edit the data to make comparisons, simply click on the down arrow button next to the linked icon of the alternative for the section you want to change. Then, select the Unlink option, for example, Unlink Weather. Once the link is broken, you can choose from 3 options: Create New, Copy From, or Link To. Let's look at the System section for example. Create New Systems will allow us to create brand new systems for this alternative. Copy systems from will allow us to select the systems from another alternative and copy them to the new alternative. And finally, link systems to will allow us to reestablish the link between alternatives for the system section. All sections of the program will have these same options. Entire alternatives cannot be unlinked all at once. Each individual section, weather, building and site, systems, etc., will need to be unlinked one at a time. Let's take a look at some additional alternative features. Additional functions that you may want to use to edit alternatives include deleting, hiding or unhiding, switching the base alternative, and changing the order of alternatives. Deleting the alternative will completely remove that alternative. If another alternative is linked to the alternative that you are trying to delete, you will have to break the link to this alternative before deleting it. If you wish to delete an alternative, simply click the trash can icon to the right of the orange link icon that you used to first create your alternative. If the project has a lot of alternatives and it is a hassle to scroll through them all, you may hide your alternative by clicking the I button. This feature will collapse the alternative down into a space-saving thin bar. To restore the alternative to original size, simply click the I icon again. This feature allows you to focus your attention on specific alternatives without deleting all of the alternatives in your project. Switching the baseline alternative allows you to change the baseline from the default of alternative 1 to any other alternative. The icon next to the Collapse Alternative button is the Make Alternative Baseline button. Simply click this button on Alternative 2 to change it to the baseline. Note that the baseline alternative will always be the first alternative on the screen. Finally, if you have multiple alternatives, you have the option to reorder them. Changing the alternative order allows you to sort the alternatives in the order you would like to see them. In the upper right-hand corner of the alternative, you can click and drag the 3 black bars to reorder your alternatives. The only time this will not work is if you are trying to move a non-baseline alternative into the alternative 1 position. Any additional alternatives apart from the baseline can be rearranged in any desired order. Next, let's take a look at the Calculate Results tab. This tab will allow us to calculate the project file. First, select the alternatives that will be calculated using the checkboxes to the left of each alternative. Take note of the last run time, last run method, and status. This information is nice to see when and how the last time the alternative was calculated. The Time Series Visualization toggle button turns on the Trace 30 Plus visualizer. The visualizer is a custom report generator in which the user can choose which input or output variables to look at rather than viewing the Trace 30 Plus standard reports. Once you toggle the switch to the on position, you can click on the Select Time Series Variables tab at the top of the screen and select the specific variables you wish to view in the visualizer. Expand the filter options to drill down to specific desired variables. Once all desired variables are selected, you can either save the variable set as a pre-configured option using the Save Custom button, or you can go back to the calculation status to start the simulation. The quantity of variables that will display in the visualizer can be seen on the Calculation Status tab next to the Time Series Visualization button. Once you have the alternatives that you wish to calculate selected, you can start the analysis. After an alternative has been run, you can click the Errors icon to view any errors associated with that alternative. Before we get into reports and data visualization, let's discuss the features in the Simulation Settings tab. You can access this tab by clicking on the Simulation Settings icon or by clicking on the tab itself. In the Simulation Settings tab, there are 3 subtabs: General Settings, Load Design Parameters, and Energy Simulation Parameters. These 3 tabs will allow you to define much of the information relating to how your file calculates both the load design and energy simulations. Since we are focused on load design in this tutorial, we will not discuss the energy simulation parameters. Simulation settings input fields include simulation start and end dates, simulation time step, cooling and heating design sizing safety factor, solar distribution method, and much more. For the sake of time, we will not go into detail about these fields. Please use the F1 Help feature to find out more about each of these inputs. Let's finish our example by creating an alternative, calculating the file, and comparing the results. We will run a comparison of a UFAD versus a computer room unit system for the data center room. First, create the second alternative based on alternative 1. Click on the Project Summary tab and create a linked alternative by clicking the Link button at the top of alternative 1. This creates a new linked alternative that has identical information in each section to the source alternative. Give each alternative a unique name to describe what is being compared. Let's call alternative 1 Data Center with UFAD and alternative 2 Data Center with CRAC for computer room air conditioner. The second alternative has now been created, so now we need to unlink the system section from alternative 1. Click on the arrow next to the link symbol of the system section and select the option to unlink systems. The system section of alternative 2 is now editable. Change the data center system to a computer room unit instead of the original UFAD system. Keep all remaining defaults the same. To do this, delete the data center system from the Select System tab. Then, from the Cooling Only category, select CRAC or Computer Room Unit and click Add System. Make sure to assign the data center room to the CRAC system that was just added. Now, let's run both alternatives and discuss the reports. There are a number of standard reports available to view the outputs of the load design calculations. We will take a brief look at each of these. The Room Cooling Load Components report gives a breakdown of each element that causes a cooling load in a particular space, including people, lights, wall conduction, ventilation, etc. A donut chart gives a visual representation of this load breakdown. These loads are displayed at the peak time for a particular space. There is a separate page that describes each room. The instantaneous load column represents the exact load at that hour and ignores any thermal mass effects of the building. The time delay load column is more realistic as it does consider the thermal mass of the building. The Room Heating Load Components report is formatted in the same way as the Room Cooling Loads Components report and shows the heating loads in the space at the time of peak. The Zone Cooling Load Components report is very similar to the Room Cooling Load Components report, but gives the block load for each of the zones instead of the individual rooms. The Zone Heating Load Components report is again very similar to the Zone Cooling Load Components report, but shows the heating loads for each zone. The System Component Summary report is the best report to use when sizing your equipment. This report shows each of the coils, fans, pumps, and plant equipment at the appropriate level. For example, a system level coil in an air handler versus a zone level coil in a PTAC unit. This report gives sizing information based on the design load calculations. The Design Psychrometrics report gives detailed information about the psychrometric data at each point in the system. This is a useful report to see how the air is being conditioned throughout the system. The Outside Air Summary ASHRAE 62.1 Analysis Report will only contain data when the program is set to do ASHRAE Standard 62.1 calculations. This report shows all of the variables that are used in the 62.1 calculations to help you understand how the program arrived at the final ventilation values. Finally, the plant summary report gives block and peak sizing information for the plants. That's it for our example. That concludes the Load Design 101 tutorial videos. We hope you now have a better understanding of how to use the load design portion of TRACE 3D+. If you have any questions about the software program or any other related modeling or CDS software questions, please feel free to contact the CDS Support Center at the phone number or email listed here. Don't forget to use the F1 Help feature within the program, as well as our e-learning videos and answers that are located on our website. Thanks again for watching, and we wish you continued success.